back. This is video number 2 for 11.2, or actually video number 2 for 11.4. And before I move on, there was one error I made in the first video. I'll let you decide what that error is. It's related to a number that I brought over to the first page. But see if you can find that error and fix it for us, and that's going to change the percent. But I'll challenge you to find that mistake. In this particular video, what we're going to do is, again, more work with conditional probability, but this time we're going to use a little different strategy. It's called a tree diagram to help us visualize the problem. So the first step is to actually read the problem, number 8. And this says, a student in Buffalo, New York made the following observations. When snowfall is heavy, greater than or equal to 6 inches, then snow is closed 80% of the time. When snowfall is light, then this school is closed 30% of the time. 40% of the snowfalls are heavy. So what we did, or what I've done here, is created what we call a tree diagram with this key attached here. So we use just letters to represent each event here. For example, H is heavy snow, L is light snow, O is open, school is open, and C is school is closed. So here's the art of this. What you have to do first is draw a nice tree diagram, a picture of what's taking place here. And I did that. First, I assumed it was snowing. That's our starting point. Then, as you can see, it says 40% of the snowfalls are heavy. So I made a branch that went off to H, which stands for heavy snow, 40%, which is 0.4. We know that if 40% of the time it's heavy snow, then there's going to be 60% of the time it's going to be light snow. Remembering that these first two branches has to equal 100%. So we've got our first two branches, whether it's heavy or light snow, assuming it is snowing. Then the second set of branches come to us this way. It says if we have heavy snow, there's an 80% chance of it being closed. So we make an assumption here that we have heavy snow to get to this point of our tree diagram. The problem says that 80% chance of it closing. Then, of course, there's a 20% chance of it staying open. If we have a light snowfall, then there's a 30% chance of it being closed, or 0.3, and then 70% chance of it being open. Please remember that these two numbers here must equal 100%, as do these two. Now, once you have this diagram set up, it's fairly easy to use. Like sometimes they're as easy as number 1. It just says probability of heavy snow. All you have to do there is look at your tree diagram. You're going from it snowing to heavy snow. It's 0.4 or 40%. The actual problem gives you that directly, so we just write that down. Problem number 2 states the probability that school will be open given that we have heavy snow. Probability that the school will be open given that we have heavy snow. So what we're doing in number 2 is we're assuming that we're at this location right here. We're at heavy snow. That's our assumption. What's the probability that school will be open if we're right here? And that's 20% or 0.2. So that becomes 20%. So this is a conditional probability where we're saying, okay, probability of school being open given the fact it's heavy snow. We jump to this location, then we calculate our probability that it's going to be open. Just likewise with number 3, we calculate the probability of being open given the fact it's light snow. Again, we're jumping here now, and then we want to know, since we're assuming it's snowing out and it's light, probability of being open there would be 70% or 0.7. And then we calculate number 4. Now, you'll see in number 4, 2 and 3 are good examples of conditional probabilities. 4 says probability of light snow and it being closed. We want both of these to happen, light snow. So we want to take this branch here. We want it to be light snow, and we want school to be closed. We want both to happen. Now, in the previous examples or previous lessons, we said correlate and means the times. So we're going to have two events that we want to have happen. Probability of it being light is 0.6. Probability of being closed is 0.3. And we simply multiply them together. We get 0.18, or an 18% chance of us having light snow and having it being closed. Now you try number 5 on your own. I'll hit pause. When you come back, it will be completely done for you. Okay, welcome back. Hopefully my answer matches yours. We want it to be heavy snow and close. We want both of these branches to occur. So 0.4 is heavy snow, 40%, 80% is going to be closed. To have both of those happen, we need to multiply them, which is 0.32 or 32%. Now I added one more here that I thought we'd better go over, number 6. As a student, you probably want to know, okay, what's the probability of just having school being closed, period, if it's snowing out? So if you look at this, there are 2 branches that can happen here for us to have snow called off. We can have heavy snow and have it closed, and we can have light snow and have it closed. And we've calculated both of those probabilities here. So you're looking at light snow as 60%, and if it's closed, 30%. So we've got an 18% chance of light snow occurring and having it closed, and then heavy snow, we have a 32%. Sometimes you just add these two together. So we would take 18% plus the 32%. So we have if it snows out, we have a 50% chance of having school closed. The reason for that is, again, because we have 2 ways for that to happen. If it starts snowing out, it could be closed this way, or it could also be closed using this branch. And what you have to do is calculate both of these individually and then add them together. So we have a 50% chance of school being closed if it's snowing. Hopefully that went well for you. Now what I want you to do is number 6, create your own tree diagram this time. And it relates to Jim's favorite restaurants. So take time out and try and create a tree diagram and see if you can answer the question. Okay, welcome. As you can see, I've created a tree diagram that describes both of these situations, or this situation. Jim's favorite restaurant serves soup 80% of the times on weekends and 30% of the time on weekdays. It says use a tree diagram to find the probability that Jim can order soup on a randomly chosen day. So first of all, I created a little key here. WE in my tree diagram is weekend, WD is weekday. And I think you know what we're going to consider a weekend, Saturday and Sunday, and there are 2 of those days out of the 7. And of course, weekdays are 5 out of 7. There's Monday through Friday. And so our probability of just showing up at the restaurant and having it be a weekend is 2 out of 7. For it to be a weekday is 5 out of 7, which created our first set of branches in green. Once we get to our restaurant, if it is a weekend, we have an 80% chance of soup. Soup is S, and a 20% chance of not having soup. If it's a weekday, 5 out of 7 chance of it being a weekday, 30% chance of it having soup, 70% chance of not having soup. So what we want to know, he's saying, okay, if Jim shows up at random, what is his probability that Jim can order soup on a randomly chosen day? So he has 2 ways of doing this. First branch is it could be a weekend, 2 out of 7, which he has an 80% chance. So the probability of it being a weekend and getting soup will be calculated this way. Probability of being a weekend is 2 out of 7 times the probability of being soup is 0.8. Use parentheses here. Okay, so that probability right there would give us the probability of showing up, picking a day at random and having soup. Then we have to add to that, another way of doing this, we could actually show up on a weekday, which would look like this, 5 out of 7, times our chances of getting soup there is 0.3. Now what you do, and I'm going to do next, is simply take my calculator, multiply these probabilities together, and then add the results. And that's going to be the probability of Jim being going to that restaurant on a random day and getting soup. Okay, welcome. As you can see, I calculated. Now, one probability is measured in a fraction. That's no big deal with your TI 83s and 84s. They'll just accommodate you with your multiplication. You get 0.229. And then that's for us to get, if we pick a day at random and getting soup on a weekend would be about 22.9%. And then for us to get have soup on a weekday, if we happen to pick that day, it's about 21.4%. Adding them up, we get up 0.443, which is Jim's probability of having soup at any given day showing up at his favorite restaurant would be about 44.3%. So hopefully that made sense. Watch the video as many times as you need and let me know if you need help or have questions. Thank you.